sounds like, Chris. All right, so this is coming from the perspective of what's called the Spatial Web, which is from the Spatial Web Foundation, and it has some really, I think, opportunities for connecting with OGC because it references OGC standards in the Spatial Web spec. I want to give an overview of Spatial Web and the Foundation. Second, I'll go through some technical detail in the standard that's been approved by IEEE called 2874. It was approved earlier this year, Spatial Web Standard. It's an architecture, it's got 3 viewpoints, stakeholders, a conceptual model, and distributed computing. There's a modeling language, HSML, that comes along with the conceptual model, and there's a transaction protocol that comes along with the distributed computing. And then with that in mind, we'll introduce some ideas that, maybe there's some opportunities. The general theme is that I think a lot of us are trying to design ecosystems, we put it plural, of agents. We'll talk about what is an agent, right? Not at all clear what an agent is, that utilize connected systems. And so I did throw connected systems in there because of this presentation, but the ideas are very similar. So that's the outline. Let's do the overview. Spatial Web is an interoperable world model. So we take a lot of ideas from the last 15 years of AI models, where they have been using very high dimensional spaces and creating world models that agents can use and share. It's targeted at cyber physical systems, so not just agents that are workflow that get your calendar updated, but agents that include robotics and are able to do physical things with cyber connections. Autonomy is a big deal. And the vision, shared world of AI agents, robot people to have a common understanding of the universe. So there's very much this notion of for the good of mankind. Spatial Web Foundation is a not-for-profit and aims at defining the spatial web. We use a pattern, which is very familiar. It's called the web, where the web was a set of primary objects were hypermedia documents, right? So you go on the World Wide Web, you get a document. So that's a good thing. You get access to that. We can model what a document looks like. It has a bunch of multimedia parts. In the spatial web, we're looking at cyber physical entities. I'll show you the parts and the ontology associated with a cyber physical entity. HTML, a markup language, actually markup for those media documents, becomes a modeling language, a hyperspace modeling language. Similarly, HTTP becomes hyperspace transaction protocol. And where the world of the web is web domains, we're talking about spatial domains, and I'll tell you what spatial domains means as we move along here. So that's kind of the approach. There's a book written by a couple of guys a few years ago that laid out the vision called Spatial Web. A key thing of this whole set of infrastructure is the grounding for AI agents. And what better grounding for AI agents than space and time? That wasn't a joke, but I thought it might land. Space and time is, pretty important to this group and pretty important to agents that live in the world. Also context, the relationships between them, and credentials, something that is not well addressed yet. So the rights to be able for an agent to do something, the permissions, the contracts, the laws, the norms, all of that fits into the grounding elements for AI agents. So that's the scope. It has gotten attention by Gartner. They have this radar called Spatial AI, which is broken down in a variety of areas. Spatial AI includes HSML as a trend on its own within that landscape. HSTP is listed by Gartner in the Spatial Web Protocols, and the Universal Domain Graph, which we'll speak about a little bit more later, is part of Spatial Web Systems. Their recommended action is to experiment now with HSML. Use the SDK that's available and open to do that experimentation. Gartner was a member of the working group, the IEEE working group, kind of sat back, and I chaired the working group, and they never really kind of brought themselves forward until they released this radar. I was like, yeah, he pretty much nailed it. I was like, well, yeah, it's because he was in the working group. So, okay. So let's switch to what got approved then. which is this standard. IEEE has a standards association, does all the same kind of things that OGC does with respect to open and consensus and fair and balanced, has produced, tens of thousands of standards. The full name is the Spatial Web Protocol Architecture and Governance. It was approved May of this year, and it was declared a public imperative in order to address some of the social issues associated with AI. IEEE has taken a very strong social consciousness associated with AI, whole other group that does that, but they saw the spatial web as part of that public imperative. All right, so we'll go through the first viewpoint, which is, stakeholders, and what does it do? Who do we apply it to? Here are the scenarios that it is aiming to address. It ranges from indoor, urban to global. It ranges from enterprise, community to humanity. And so each of these in the boxes then are application scenarios, which in the standard, it shows how they are achieved. So a warehouse robot, industrial XR is a guy, a mechanic on an airplane with a torque wrench that's got, smarts to it. Cultural location tourism is a bot that understands the norms. Logistics, global supply chain, urban digital twin, in particular smart city for energy is one of the main ones we're working on, and I think resonates well with connected systems. Digital Earth, which includes greenhouse gases, establishing a marketplace for greenhouse gases where the agent is the mediator between sequesters and producers. So that's the, and then there's a pure metaverse one, the entertainment XR. The conceptual view, this is the basis of the ontology on which the entities are defined. So each of these items in this, in the lighter gray, are entities, and they sit into these categories. So what's the most important thing for entities? It's space and time. So we put space and time at the bottom, and we include hyperspace, which includes four-dimensional space-time, but it also includes this very high-dimensional spaces, thousands of dimensions in which you can do a vector that identifies a concept, right? So that's a big deal of spatial embedding that made LLMs kind of work, right? Was the ability to have vectors that you could compare and get a logical conclusion out of language based upon comparing vectors in thousands of dimensions, okay? Above that, things that persist through time. So these are the things that persist in time, have identity over time, and those are the key thing we identify as domains. And so we'll see geography there, we'll see things there, we'll see people there when we get into what is a domain. But those are the things that exist, persist over time, and have identity that persists over time. Describe change with things like agents, which cause change to the domains. Talk about activities where they may agree upon an activity in order to carry out some activity, a workflow, but in a cyber physical space. And then governance on top of that, the ability to have credentials. So the agent has been certified to do this task in this environment, in this context, by a third party. So when you go find this agent, you can look at its credential and you can be rest assured, or at least obtain a warranty, that it has the credentials to do the job you want. Norms and contracts are also part of that governance. So that's the top level of the conceptual view. Let's take the one at the bottom, space and time. This is where HSML falls out. HSML encodes these entities that are part of the spatial web ontology. So here's our notion of hyperspace. Look at the item right in the middle. Very general definition of space, hyperspace. It's a set of elements related by paths. So this is not just your coordinate systems. It's not just a graph. It's not just a cellular space. It's all of those, because all of those are a set of elements related by paths. So this is the notion of space as connectedness. This is the notion of space as if you have something close by, it's probably important. So that's the notion of hyperspace. We define a bunch of different types of spaces, types of hyperspaces. The typical thing of a geographic space down on the lower right that includes a couple of different coordinate systems. The vector spaces that I mentioned, that you're able to semantically differentiate between apples and carrots based upon the cosine between those two vectors. and the notion of graphs. So graphs are nodes connected by links. Hypergraphs build a concept of containment around the nodes or vertexes. And then cellular is a type of graph that has a very specific geometry attached to it. And actually became a significant way that we demonstrated the connectedness of all of these spaces was geography. So we know we have, geographic CRS, WSGS 84 lat long, something you guys know like crazy. We also then on that define a DGGS, a discrete global grid, which is here, it's referenced in the IEEE spec. And out of that cellular space, you can pull out an index, a graph of the DGGS index and put it into a graph network and then treat it as a graph. Might even be a semantic graph at that point. So the ability to go back and forth between these, there's some people doing some really crazy work on category theory that I don't understand and I won't try to understand, but it tries to bring a common interface to all of these spaces. Okay, so that's space and time. I didn't speak much of time, but time is a dimension. Oh, there's also time as an agent sees it, as it experiences it. That is in the future, current, present, and in the past is also described. Spatial web domains, there's 6 types listed here. We don't think they're fully normative, but we put them in for working at this point. So geographic, it's a feature. A domain is a feature. If you hadn't already figured that one out, so I bring that up every now and then. But abstract ideas, concepts also fit into this hyperspace, right? Using the spatial embedding techniques, you have hyperspace of concepts. They're domains. You would get a concept of thought that's related to each other. An organization, an agent, which has active states and agency. A person, it's a type of an agent with self-sovereign identity, it's a human. And a thing, bounded items without agency. These are all related in this spatial web space by graphs or hyperspace, and we term that existent network the universal domain graph. Some kind of like the World Wide Web, the links between all these domain nodes. So it's a universal domain graph that allows you to traverse links and find things relevant. And we're building out the various concepts of UDG, Universal Domain Graph. That allows us to bring up this kind of speculative idea about hypergeography. So I've mentioned spatial embedding, and it's the tech behind LLMs. Go look for this Canerva 2009 paper on high dimensional computing. So this is well-known math. It was behind what was called Word2Vec. So there is this open source software that allows you to take a string of words, a language, a corpus of language, and turn it into vectors using Word2Vec. And the idea then, that LeCun actually put forward from Meta, is to extend that to World2Vec. So now we're talking about the cyber-physical entities that we've enumerated and creating a spatial embedding of that. That allows us to do two things, an analogy calculation. So these vector spaces allow you to say things like Russia is to Moscow as US is to what? And it will come back and say Washington, D.C. We don't know how this works. Literally do not. The textbooks on this topic say we do not know how this works, but it works. Okay. Even more interesting is the recent LLMs that have come out, various people doing these large language models with different engines and different kinds of things. They end up coming up with embeddings that look similar between their spaces. So they create a UDG, if you will, and another UDG is created, and there's similarity between the features in their embedding that are similar between the two. Boy, that might be really useful for semantics, right? We're able to define things, we're able to see relationships that are able to be compared. We need a space for this to operate. We call it hyperworlds. We need the notion of a hyperspace reference system that has, if it's a coordinate system's easy. It's 10,000 dimensions, right? The datum, what is your datum in a conceptual space? Is it a word that you all agree on the same meaning is going to have this value in that hyperspace? Maybe. Features in hyperspace, you know what a feature is, a semantic entity that may have more than one geometry in a space. It's the same notion that we're talking about in hyperspace. And that allows us to come around to our first law of hypergeography, which is things that are close in hyperspace probably have some relationships that are of interest. We ought to exploit that. This is a little speculative. It's not in the spec. It's in the UDG design spec that we're currently working on. I'll pause there because that's the domain and space stuff, and I need a drink and maybe, and before we, okay, so that's space and domains. Moving up the stack, we're going to talk about agents. Agents and entity. Remember, that's in our ontology, everything's an entity. Every entity has an ID. Agent is an entity that senses, responds, and maintains a goal of its environment while performing activities to achieve its goals. This is the textbook definition of an agent, and it's also now in the ISO standards for agent. Actually, the model may not be there. The goal is there. I think we added the model. And we declared our environment to be domains. Anyway, this is what an agent can do, a performing and requesting agent. Performing agent forms a contract around an activity, performs that activity, and then satisfies the contract. Types of agents. So there's a range of agents. A lot of the agents that we have right now are come from contemporary AI, which is about workflow agents. And those are in here, but they're not prominent. Same with LLMs. Those are in here, but they're not prominent. They tend to be functions as opposed to what we call as types of agents. The taxonomy that we came up with types of agents comes from natural intelligence, natural agency. So in particular, there's a body of work by anthropologists and psychologists and the like called the evolution of agency, and it builds a goal-based agent. So a goal-based agent essentially has memory and creates a very base model, and it has feedback control. So a goal-directed agent is a control system. And actually happens to be what a lizard does. So their parallel to that is a lizard. The intentional agent is a rat or a mouse. It does things like vicarious trial and error. It has intentionality. It looks around. There's some connection to the OODA loop in that regard. It's about quickly, it's a level above or a level slower in timing than a control system, right? These tend to be, the loop of timing tends to be longer as we go up. And so an intentional agent is a rat, for example. Rational agent has causal models, plans for the future, does causal learning, is able to recognize minds in other agents. So this theory of mind, that I recognize that agent that I'm looking at over there has a similar kind of intentional or rational understanding of the world that I do. And then a social agent. You're able to form joint goals with other agents, joint planning. Right now, this is humans. Will this be more than humans soon, someday? We'll see. One of the key funders of the Spatial Web is a company called Versus, and they're building technology that's based on technologies called active inference. This is Professor Carl Friston. This is his work on active inference, where you, again, have sensors and actuators. You have a probabilistic model of your sensor and actuator as well as your model of your world. It's a world model that's being created using a POMDP, a partially observable Markov decision process, has Markov blankets delineating the edge of the agent. It's all the very high end, but he's now, Carl Friston has identified free energy principle, which looks very prominent and useful in creating agents that are much more capable than what we have now. And so this is interesting work. Carl Friston's our chief scientist. All of that goes into HSML then, all of the space, time, domains, contracts, agents, and so HSML modeling guideline. This is a slide from Stefan Fella. Some of you may know Stefan Fella. Stefan is doing this work of HSML modeling. He wrote the HSML spec. All right, so that's the conceptual viewpoint, the second of three. Third viewpoint is a distributed computing viewpoint. We start out with, a layered diagram from physical devices, edge, cloud, and user clients, just to be able to identify nodes, computing nodes, which communicate in the spatial web using HSTP. So this is kind of the overview of that. HSTP has a conceptual model that identifies the operations that is then have several bindings, HSTP, the message binding, which is MQTT, web APIs and the like. And we're using W3C's DID, distributed identifier spec for identity. So every entity in the spatial web has an identifier. It's called a spatial web ID. It's called a SWID. SWID, the syntax for the SWID is a DID. DIDs have the name DID, DID method. And then that's where it becomes specific, and we define a SWID DID method for our DIDs, which are SWIDs. Anyway, all right. So that's the spec. Let me give you a sense of what it does right now. Prototypes that have been built.
The spatial web is an interoperable network of people, places, and things, built on open standards developed with the IEEE, including HSML and HSTP. HSML, or Hyperspace Modeling Language, is the lingua franca of the spatial web, a shared language for humans, machines, and AI agents that makes mutual understanding and intelligent automation possible. HSTP, or Hyperspace Transaction Protocol, is the communication and transaction layer, backed by credentialing and verification to ensure trust, privacy, and security. Another vital part of the standards is the Universal Domain Graph, or UDG. At the micro level, the UDG enables agents to share knowledge and collaborate. At the planetary level, it allows agents to coordinate in solving global scale problems. Any agent can use the UDG to look up what data, devices, sensors, and rules are available and applicable in a domain, query their states, and instantly understand the necessary context to perform optimal actions to achieve the desired goal, effectively, efficiently, and safely. Recognized by the IEEE as a public imperative, these standards rebuild the web's foundations, so the spatial web can serve humanity in a way that's safe, just, and equitable, on Earth and beyond, unlocking new possibilities for the future.
But I like it. All right. So there's some, those were in case the video didn't work. But this actually has more pictures of the lunar project with JPL. It's two rovers that are doing rendezvous and surveys on the south pole of the moon without human intervention. Okay, so that's spatial web. That's the spec. That's the standard. When Peter suggested to go look at connected systems, I said, hey, that looks like sensors and actuators and things that I love. And so I'm taking a look at that. I think there's some common patterns between the two pieces of work, spatial web and connected systems. I think there's some common use of semantic standards. Again, not a mistake, not a coincidence. Common domain scenarios. I'll talk about the smart city momentarily. And so maybe there's some opportunity to align. These are the things that I looked at and pulled out some material from them like this. So here on the right is a figure that you guys here in the room should recognize, right? That's connected systems with sensors and actuators. Oops. Observations and command, data streams, control systems. And that's what we're doing with agents that have sensing and actuation. We use HSTP to connect the data streams, which are HSML. And so how might we put some of the data stream description that you're describing in connected systems into an HSML payload, for example? How might we put commands, the would come out of HSML into a connected system actuator. It seems pretty straightforward in the sense of the mapping of concepts. So there's that one. And then there's in the overview document, I think it's the document's called the overview document for connected systems. Reviewer's guide. There you go. The reviewer's guide. Wonderful document, man. That's like, I want to do all that. Has this smart cities scenario in it. And all the stuff that's in there looks like what we're doing with spatial web, urban digital twins. We're focused on energy. We've got a couple of different hyperspace representations of the energy network of California, both a connected graph as well as a geographic space, and how do you go back and forth between them. And this notion of multi-scale cognitive computing within the UDG, that you have entities in the UDG that are able to serve as supervisory roles and the like, may also be something you're thinking about in the Smart Cities Connected. And it gets back to next generation cities in the globe, benefiting the next generation. That's what I have.
Konnichiwa. Okay. We have this dream, right, in OGC 20 years ago, build a sensor web, connect worldwide sensor into coherent system of systems. And then I think we got some results, meaning many, many sensors, maybe millions, or I don't know how many, using, for example, sensor things, share data. However, my nightmare is right now 1 billion sensors, right? So sensors are just numbers growing like crazy. And then although we start to see some interoperability in certain area, but the speed of growth of sensors, right? And the diversity of those sensors just grow even crazier, much crazier speed, right? So look at this, again, the vision is there, right? How to connect everything together. I'm just thinking about what's your thoughts about this world dominance, the plan to dominate this world of sensors. I don't know, just throw a question. It's maybe not just for you, it's for everybody here, right? We have this vision, right? So, but how do we go get there, right?
Your last bit there, we're all mostly engineers in here, computer programmers and the like. Occasionally, we're good engineers in the sense of we think about societal impact. And in particular, this notion of the UDG, which is this graph we've made some estimates, 10 to the 12th nodes or something. It's just ridiculous. And we look back on what happened with social media of a graph of maybe not quite that big. It's like 10 to the 8th or something, I think, social media. In any case, the paradigms and the drivers for the way things happen in social media right now is something we don't want to repeat, right? We want to provide, and we have to balance this. We know that we as engineers can't mandate some global view. We knew we have to allow for commercial capital investment to succeed, but we still need to do it in a societally equitable way. That's a real challenge.
You mean that the world will start using our standards because of the goodness of our heart? Or again, I'm just thinking about how to. Oh, Chris said money. Okay. Anyways,
we're not a big part to that. So that Gartner thing was huge, right? Because it's telling the Gartner group gets all of those high money companies a direction that they should go. And so getting on their radar with Spatial Web could be something very valuable in terms of that uptake.
Yeah, uptake. Yeah, the strategy for uptake. That's anyways, just throw out the concept idea there.
Good. It's speculative. So
Thank you. Chris offer the answer. Money.
It's Chris Little. I was banging on about this to Chris this morning, Chris Tucker, And the temporal domain working group has been a bit in abeyance, but I'm trying to get some new life into it. And I just wonder whether in all of the HTML, STP, and all that kind of stuff, and the universal domain graphs, have you made the assumption that everything is running in the same time? They all have the same clock? Or
Been a
some of the
big
systems
discussion.
disconnect? Yeah, they're connected. They become disconnected. They reconnect. How do they know the agents have got the same time?
Not a solved problem, but there's a lot of issues as you've just begun to identify. Certainly making use of Internet Time Protocol is going to be there, but there's also this notion of, especially as agents move and cause activities to happen, what are the triggers in time, and is there a heartbeat associated with that in some
And
way?
they will be working in a DDIL environment.
Say again? Oh yeah, right, yeah.
Okay. So,
Well,
and I think that's going to be a kind of fundamental thing for agent.
have requirements for DDIL. In particular, it was like I made sure that identifiers didn't require a network accessible um, service in order to create an identifier, because you're going to be somewhere within either a DDIL or just your local LAN or something. You're going to want to create identifiers that are globally unique, even though you can't talk to the world. That was a tough one for people to get their arms around.
Yeah, George, Jim Anthony's very enjoyable. I don't know if I'm taking you back to the place we were punting on categorical category theory, but I was really interested in that image of the four different types of representation. The one on the right was the hyperspace, and I think of that as a LLM, in which that's where concepts live for these new machines we've got. And then the other three looked really crisp. And so, are you suggesting that in through category theory, those crisp representations will be communicable between different agents that have their own concept spaces? If you follow that, is that the result?
Roughly. So the idea from our category theorist was that each of those types of hyperspace would have a definition using category theory, and that there would be functors between the categories, functors between the different representations of space. And that was the bit that broke my mind.
And that suggests to me that strictly, you don't want to do it this way. You'd want to have an explicit representation of these crisp things out in our machines. But conceivably, you could have a bunch of these things with hyperspaces that are communicating as if those were crisply defined. Is that, sorry, anyway, I'll just get off the stage.
Well, no, you bring up the notion of, you know, one of the key comments that Carl Friston made on the IEEE spec was about the definition of representation. And so I had a definition of representation was something like, this is how we semantically define a thing using a representation. And he said that definition needs to include a sense of probability in it. It needs to be, a probabilistic definition, because of all the work that he does is all in, Markov decision process is all probability and the like, but it also points to how he represents the world as a probabilistic view, as opposed to, like you say, a clean cut.
Those things on the left side, from our point of view, would actually be, I think you mentioned before, kind of clusters, probabilistic clusters inside of that space.
Yeah.
Okay, good. Thank you.
Yeah. The other place that came up was this notion of an agent that is a control system, and using active inference, which uses free energy, in order to do control systems. And the notion that, with control systems, it's all about stability. It's about the ability to take the equations, which are typically deterministic differential equations. Sometimes they're stochastic, but that's advanced stuff. And you're able to identify this control system will be stable. You can guarantee that it's stable based upon a good description of your plant and the algorithms you're going to put in your control system. It was my master's thesis was on control systems. And so I challenged the people that were defining control systems using a probabilistic view, active inference in particular, how are you going to guarantee stability with this probabilistic system? I see these hallucinations happening in LLMs. Are you asking me to put a control system that may hallucinate in my car? Yeah, that we haven't resolved that yet.
More of a comment than anything, just tagging on to that previous discussion. It's an area of open research, but I think there's a space for DGGS, especially 4D, spatiotemporal DGGS on the edge as a mechanism to provide a global, unified, and unique indexing capability in a DDIL environment where you may or may not be connected to time synchronizing circuits and things like that. So just sparked some food for thought, and I think that's an area that would be really interesting to explore.
The group is at right now with respect to DGGS is they understand it and they're able to grok what H3 is because it's got code that runs. And I don't want to disrupt that right now by saying that there's other spaces in which H3 may not be the best choice, but they'll get there.
Oh yeah, but no, there are definitely those opportunities, and
have we done
it'd be
anything
really
to
interesting to see.
Get closer to H3 in the last few years?
Sorry?
Have we gotten closer to the H3 crowd in DGGS in the last few years?
They've kind of preferred to talk amongst themselves and keep doing
But nothing
their own
different.
thing. The H3 DGGS kind of falls under the broad umbrella of the OGC standards, but that community, they've come in, engage a little bit, and then go and talk amongst themselves in their own little bubble. But
area cells.
it doesn't. But I guess, for the use cases that are often being used, that's not a critical
problem.
factor.
That's where I'm right now too. It's not statistical data that they're working
Yeah,
on,
that's exactly right. But I can see this as being a framework that can support not just the Uber and H3 use case, but the more statistical use case in terms of a spatial markup language and communication language. And to be honest, just sort of have a DGGS or an spatial indexing box, whether that's filled by H3 or some other DGGS.
That'd be interesting.
There is,
we need that flexibility. That's very true. Cool. Yeah, good comment. Hey.
My question is now technical things. So how can we give them IEEE to our feedback? Also, how can we can get the information from IEEE related of the sensor web?
The spec itself is developed within the Spatial Web Foundation and then contributed to IEEE, much like OGC contributes specs to TC211, all the APIs that went there and the like. So the real heart of the work is happening in the Spatial Web Foundation, and IEEE provides the ISO equivalent of internationalization. So it depends upon what you want to connect with. If, for example, we're looking at an IEEE ISO connection, which actually I'm on IEEE AI Standards Committee, and we attend ISO AI committee that you were just briefing about. There was, what's his name there? Anyway, that could be one way to make the connection. The other is between OGC and Spatial Web.
Thank you.
Yeah. I think that exceeds my time, Chris.